All right, in section 7.2 in the book, you were studying rational functions, and remember, rational functions are just functions that are actually fractions. You can look at the top as one function, and the bottom is another function, and you put them over each other, and you've got another function, a new function. Let me call this one f of x. Okay, now, in our book, we're trying to learn how to graph these, and we're going to learn some more things about them later on in this chapter 7, if in our current book. But one of the things that we're going to learn first is how do we find things called discontinuities. And if you remember from in class, discontinuities were either one of two things. There were places in the graph, first of all, where there is no, an x does not have a y value. It ends up being an undefined value, and that happened, we saw in class, because we could get 0 in the denominator. So one kind of a discontinuity as a whole, that happens when we factor the top and the bottom and something cancels out because it is in both the numerator and the denominator. So that's the factor that cancels out. Now, a whole, let me write that down, a whole is going to have values on either side of it. It's just one particular value. Because those factors canceled out, you'd get an undefined fraction if you plugged that x into the equation, and so it doesn't have a y value. There's something else that's called a discontinuity, and it was an asymptote. And for an asymptote, you have, okay, after you've canceled out anything that will cancel out that might be a whole, any factors that you have left in the denominator will give you asymptotes. And how we find out where these are is we take these factors that we're finding, either the ones that cancel out or ones that didn't cancel out, whatever they are, they're occurring in the denominator, and we set them equal to 0, and we can find where a whole is, or we can find where an asymptote is. So if we want to graph the function, I'll probably do that on the next slide just because we'll do a little bit of work here. If I want to graph the function, that can help me graph it. Now, if I were to try to graph this function and all I did was pick a bunch of x's and graph it, I might not get a very accurate picture of what's going on. If I first take the time to find out where there might be some asymptotes, especially wholes also, but asymptotes are a little bit more helpful, then it's going to help me graph this function. Now, there's something else going to happen in this function that we're not going to be studying today. We are studying vertical asymptotes today. When I go to graph it, you're going to notice there's another kind of asymptote, and we'll talk about it when we get there. But right now we're focusing on these things, and what we'll do to help us graph is find these asymptotes and wholes, and then we'll use some values close to there, and we'll look at the table of values in the calculator. We could sit and plug in things by hand, but the calculator is going to make this process go a lot faster, so that's what we're going to do. I would allow you to do that on a test. Okay, so first of all, in order to know anything about this function, I got to factor the top and the bottom if it's possible to factor them, and it is. If you look at the top, that one is x minus 4, x plus 3. We said, remember, we were thinking what two numbers multiply to give me the minus 12 on the end. We even had this little organizer that helps some of you. I'm looking for two numbers that multiply to give me that negative 12, and at the same time they have to add to give me the b coefficient. Remember, we could label all these functions ax squared plus bx plus c. I'll just write it up here once. The b on the top function is a negative 1. So what two numbers multiply to give me negative 12 and at the same time add to give me negative 1? Well, that was negative 4 and 3. So that's why I factored it the way I did. I took this negative 4 and I stuck an x with it, and I took the 3 and I stuck an x with it, and that's how I factored the top. You can see that your factoring is going to be important in this section. Now I need to factor the bottom. And remember, we're trying to again, this little simple way of factoring, it only works if we just have a plain old x squared here. If it has a number in front of it, it's a much more difficult problem. But this one's an easier one to factor. What multiplies to give me 20, and at the same time, the same two numbers adds to give me that middle coefficient, negative 9. Well, let's see, negative 4 and negative 5 would multiply to give me 20, and they would add to give me negative 9. And it may take you a little longer to find it than what I just wrote down. I just don't want to burn up the video, thinking about, how we would do that. You'd have to kind of think about all the different ways you'd multiply to get 20 and look for things that might have a difference of 9 in them, and then you could tweak your signs afterwards. We'll be kind of reviewing that in classes a little bit. And there's a bunch of videos loaded on core sites for you to watch to help you with your factoring, and they're the ones that I did for Algebra 1 this year, so they might help you too if you go back and review them. Anyway, I would take this -4 and I would put an x minus 4, and I would take that minus 5 and put an x minus 5, and I would have it factored. Now, let's talk about wholes and asymptotes. If you notice, there's something that's going to cancel out. I always look for things that cancel out first, and this x minus 4 cancels out in both of them. So that means x minus 4 is a whole. And to find out where the whole is, I set it equal to 0. Remember when we solve things, we're always setting them equal to 0, so it kind of makes sense here that we would do it too. This is going to tell me where I have a whole. And the whole, remember, it will be an x value that does not have a y value. And so when I go to graph it, I'll show that on my graph. The calculator will not show you this. You cannot trust your calculator to tell you everything about a graph. It gives you some helpful things, but it's not enough, okay? So if I want to solve this, I just add 4 to each side. I have a whole at x equal 4, okay? So that's where the whole is. Now, for the asymptote, and this is a vertical asymptote, there's another kind of asymptote, and I'll mention it to you when we go graph, okay? But to find a vertical asymptote, we set the other factor that didn't cancel out in the denominator equal to 0. Sometimes there'll be more than one thing that didn't cancel out. Sometimes maybe everything cancels out. It's different for each function. This one just has one factor, and it's x minus 5 is the only one that didn't cancel out. So if I solve that, I get x equal 5. Now, a vertical asymptote, if you remember about what we talked about in class, it's a vertical line, and the graph's going to get close to it on each side but never touch it. So I have to write this as an equation. When I go to graph the whole, I'm just going to go to 4 and graph it. And so you would write x equal 4 for the whole. That's where the whole occurs at the value x equal 4. The vertical asymptote, you have to write x equal 5 because it is the equation of a line. It's not really on the graph, but it's what helps you graph the graph. So if I ask you what's the equation of the vertical asymptote, you can't just write 5. You have to say x equal 5. 5 would be wrong. 5 is a number. We need the equation of a line. X equal 5 is the equation of a vertical line. So we have a whole at x equal 4 and a asymptote at x equal -5. And so I'm going to go to the next slide and try to graph. Okay, so I've rewritten the information here just to kind of have it so we can use it to help us graph. Now when I'm graphing, there's some important things, and we'll kind of note everything that we already know, and then I'll kind of tell you about some other things that are going to help us here. Some other things that you probably know, you just haven't thought about it. Or you may not remember it at all from Algebra 1. All right, if I have an asymptote, first of all, the whole, I can't really graph it. It's like I got to get the general shape of the function and then just go to that whole and erase the value, the 4 there. I'll show you that in a second. If I'm going to graph this, one thing I can go ahead and do is draw my vertical asymptote. It's at x equal 5, 1, 2, 3, 4, 5. It's a vertical line. I'm drawing it dotted because it's not really part of the graph, but I can't really graph without it. So I'm going to show it, and it's going to help me guide my graphing here. Now, that's not a lot, is it? Another important part of a graph is the x-intercept. And if you remember the x-intercepts, they occur where we set the function equal to 0. I want you to think about it. I got that whole function up there. I could set it equal to 0. Now, the only part of a fraction that matters when you're setting a fraction, which is what these functions are, when I'm setting them equal to 0, the only thing that matters is going to be the top here. Because if you remember, I could put 0 over 1 or 0 over 2 or 0 over 3, but the only part that's going to equal 0 is the numerator. I can't talk. So what we do to find this is we set any uncanceled factors in the numerator equal to 0. That's how we find our x-intercept. Well, I only have that one factor up there, x plus 3, that didn't cancel out. So this is how I'm going to find an x-intercept. And it'll be a nice thing to have on my graph because those are usually really important parts of a graph. Usually in real life they tell us something. So if I want to solve for x, I just subtract 3 from both sides, and I get, there's an x-intercept at x equal -3, so -1. And again, you should always number your graph and label the x and y axis. I'm going to not number it here because when I do on the iPad, it just messes, you can't read the graph. So I'm just assume I'm counting by ones, but always number your own graph, okay? There's an x-intercept. Now, that's not enough to graph this. If you were back in the olden days before graphing calculator, you would pick some numbers. You'd want to make sure you pick some around x equal 5, like right in front of it. I'd want to pick 3. I'd want to pick 6, I'd even want to pick 3.9, and I'm sorry, 4.9, because it's really close to 5, and 5.1 because it's really close to 5 on the other side. So these would be some important ones. Let me just kind of put some values down that we might care about. It's always good to know what's going on at 0, so I'll put that also. So I might want to plug in 0. I might want to check out x is 4. But even closer to 5, let me check out x is 4.9. Can't hardly read that, but that's what that is. I'm going to check out, I know there's nothing at 5, but let me check out what's happening at 5.1. And let me check out what's happening at 6. So I still need some points, but it's not like I have to go graph 20 of them or anything. I can at least narrow down what I'm doing. I need to know what's happening on this other side. We've got 0. We've got a point there at the the x-intercept. We've already got that point. I still might want some more. Let's see what we get on the graph, and then we'll kind of see where we maybe need another point. Sometimes it's helpful just to go ahead and graph what you have. So if I go to my table of values on my calculator, if I type this in, and remember when you type the function in, you have to type the whole top part in parentheses, then hit your divide sign, then type the whole bottom part in parentheses if you want to get your table of values off your calculator. You're welcome to do it by hand. It just takes a long time. I know I grew up in the age of no graphing calculator. Okay, so let's just use our calculators. If I look at 0, I'm at negative 0.6, okay? So let me graph that in blue as I go 0, negative 0.6, a little bit halfway between 0 and 1. I'll just put it there, not a great point. You might look at your calculator. For instance, at 1, negative 1, there's a nice point. So maybe I do that just because that's a nice point. I also notice there's another nice point on my table at 3, negative 3. Since it's easy to graph, go ahead and put it on there. It'll be about here because that's going to help you also. Let's see, at 4, we're getting error. That was right. That was where the hole was. So when I get I'm going to remember that this is my hole, and I'll make an open circle there to show, because there's no point there. The reason it says error, it's an undefined fraction. It'll have some number over 0, and you can't divide by 0. Now, you have to put your calculator on ask. And remember, to do that, you go to table set, you go down to independent variable, and you go over and you highlight ask with your cursor, and you hit enter, and then you hit second quit, and that's going to get you in that mode. We did that in class. So now that I've got mine on ask, I'm going to just type in the values I want to know. For instance, I want to know some of these that are decimals. I guess before I do that, let me go ahead. I can get 6. 6 is 9. That's a nice number too. So let's graph it at 6, which is here. It's all the way up at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'll draw a point up here, okay? If I look, okay, just because I'm running out of video, I went ahead and put some other values in. I went ahead and looked, and at 4.9 and at negative 79, so down here at 4.9, really close to 5. I'm so far down I can't even fit it on my iPad. I'm going to put a little dot down here just to represent that. And at 5.1, really on the other side of the asymptote, I'm at 8.1, which is here. I went ahead and got some other values while I had the calculator up. I got at negative 6, it's at like 0.27, so at negative 6, which is about, it's a little bit above the axis. So what I can do is just connect my dots now. If you noticed, we went like something like, I really should check. Let's see, no, I can do this. We got stuff going. We got good stuff. So it's doing something like this, and it's also on the other side. It's doing something like, it's coming up like this. You need to get some more points, but I'm running out of time. Like I might want to plug in x is 7, so I could go to my table and hit 7. And at 7, I'm at 5. So 1,